Okay, let's go over the example problems. So in this one it says a space probe produces a radio signal pulse. So radio waves, those are transverse and electromagnetic. So they travel at the speed of light. They also give us the time. So they've given us the speed and the time, and they're asking us for the distance. So that's just a v equals d over t. We know the speed of light is 3 times 10 to the 8th meters per second. That's on the reference table. And then we just cross multiply and solve. In this one, they have given us a whole bunch of angles in here, but they're asking us for the angle of reflection. Remember that angles are always measured from the normal to the ray. So here's our reflected ray. From the normal to the ray, that would be 70 degrees. In this one, we have a light wave going from one medium into another. The index of refraction is different, and it says which characteristic of the wave does not change. Well, this is something that you have to memorize, that the frequency remains the same. In this one, they give us the speed of light at a particular frequency in glycerol is what? So they're looking for the speed of light at this frequency. So the speed of light is going to be something less because it's in a medium that has an index of refraction. So all we have to do is look up the index of refraction for glycerol, and glycerol on the chart is 1.47. So we put that into N equals C over V. We know the speed of light in a vacuum is 3 times 10 to the 8th. So we cross multiply and solve for the answer. This next one says, which diagram represents the diffraction of a wave as they encounter an obstacle? Well, let's look at the ones that are wrong first. This right here is reflection, the bouncing of waves. This one, there's no bending, so we do have an obstacle. And then this one is also reflection, but it's incorrect reflection. So the only one that shows waves bending around an obstacle would be choice 1. The Doppler effect is the effect that occurs when there is relative motion between two objects, either the object and the observer or the observer and the object. And in this case, the best answer is going to be this, because what is it? It's the shift in observed frequency and wavelength of a wave caused by the relative motion between the wave source and the observer. By object, I meant the wave source. So the answer is 4. Microwaves have a wavelength closest to what? Well, we can look at the wavelength of microwaves and see that it's between 10 to the minus 4th and 10 to the 0. 10 to the 0 is a meter. 10 to the minus 4th is, this is going to be a tenth of a millimeter. So what is between a meter and 0.0001 meters? Well, that's going to be roughly a student's thumb. These are actually much too large. So we have a ray of monochromatic light. Monochromatic means a single color of this particular frequency, and it's going from medium X into air. And the angle of incidence is 25. So let's look at our diagram. We have our incident ray. And this is entering into a new medium and refracting. So it's speeding up as it goes into air, so it's bending away from the normal. And we need to use Snell's law in this. We have n1 sine theta 1, and we don't know what that n1 is. We know that the angle of incidence is 25. We know that the index of refraction of air is 1. And we have the angle of 40 degrees, which we have to measure, and you're going to measure that with a protractor. So once you've done that, you can get the index of refraction of 1.52. So this one is a straight up definition. The spreading out of a wave after passing through an open barrier is an example of diffraction. Remember, diffraction is the bending of a wave, so what's it going to do? That bending is going to create spreading out.